Hello and welcome back. If you want to sketch a polar equation but you can't convert it into an equivalent Cartesian equation, then sometimes it helps to first sketch the polar equation in an r theta plane before moving over into an xy plane. So in example 5, we're looking at graphing the curve r equals 1 minus cosine theta. And you notice that figure 10 and figure 11 are two different blank coordinate systems. One has labels r and theta, and one has labels x and y. So what we'll do is we'll first look at graphing the curve r equals 1 minus cosine theta in the r theta plane, and then we're going to use that to help us draw the graph in the xy plane. Now the xy plane is the one where the r and the theta is going to mean a distance from the origin and an angle theta. Whereas the r theta plane, theta is acting like the x value and r is acting like the y value. So that one is like the regular way that we would normally draw the graph of 1 minus cosine theta. So here, we're going to draw the graph of 1 minus cosine theta, which is the graph of cosine theta, but reflected about the theta axis in this case, and then shifted up by 1. So we can just take it one point at a time, but first let me draw a scale in the theta direction. We'll have pi over 2, pi, 3 pi over 2, 2 pi. And then I'm going to draw a scale in the r direction, the sort of the y-axis, which is now the r-axis. And then think, all right, cosine theta, cosine of 0 is normally 1. And so when we do 1 minus 1, we get 0. So this is going to be the new value, the new r value. Cosine of pi, 2 pi over 2 is normally 0. So cosine pi over 2 is 0, and 1 minus 0 is 1. So we would get something like that, pi over 2 comma 1. Cosine of pi is negative 1. 1 minus negative 1 is 2. That's where it peaks. And then we're just going to draw the rest of cosine, knowing that the cosine curve oscillates. Again, you can think about this as just being the cosine graph, which normally goes down and then back up, but reflected about the x-axis, so it goes up and then down, and then shifted up by 1, so it starts at a y value of 0, which is like r equals 0, and ends at a y or r value of 0. So it looks something like this. All right. Now that we have the graph of r equals 1 minus cosine theta sketched in the r theta plane, we can use this graph to help us draw the graph in the xy plane. So over in figure 11, we're going to start to piece this together. And we're just going to take this one piece at a time. So as theta goes from 0 to pi over 2, the r values are going from 0 up to 1. So what does that look like over in the xy plane? Well, as theta goes from 0 to pi over 2, we're basically going from a line pointing in the x direction to a line pointing in the y direction for our theta. And then the r going from 0 to 1 is just going to make you go away from the origin. So as the number line, as the r number line is rotating from the x-axis to the y-axis, the r value is going from 0 to 1, going away from the origin. Let's just draw the starting and the ending points first, though. So r equals 0 and theta equals 0, that would be right here at the origin. If r equals 0, it doesn't matter what theta is, you're at the origin. And then if theta equals pi over 2 and r equals 1, then you're over here at a y value of 1. And then again, as theta is going from 0 to pi over 2, r is going from 0 to 1. Let me draw that just slightly better. So it looks something like that. It's hard to get it exactly right, but without like lots of practice drawing. But it looks something like that. So the r values are going from 0 to 1 as theta goes from 0 to pi over 2. Now the next leg of the journey is theta going from pi over 2 to pi. there the r values are going from 1 to 2. So we already know where we're starting from at x equals 0, y equals 1 at that point. Now if theta is pi, then we're pointing in the negative x direction, and r is 2, would be going 2 along that negative x direction. 1, 2. So in terms of x values, this is -1, -2, but in terms of the r number line, since it's pointing in the pi direction, you're going 1, 2 in the positive r direction. So that's going to be the point right here at -2, 0 in terms of x and y coordinates. Now again, as your theta goes from pi/2 to pi, the r values are going from 1 to 2. So you're moving away from the origin as your theta is rotating from pi/2 to pi. It's going to look something like this. Now, as theta goes from pi to 3pi/2, r is going to start to fall from 2 down to 1. So at 3pi/2, you're going to be along the negative y direction, and an r value of 1 is going to move you down the y-axis to 0, -1. So that's where you're going to end up at. You can think of translating the r equals 1, theta equals 3pi/2 point into x, y coordinates, and you'll get 0, -1. So then r, again, as theta goes from pi to 3pi/2, r is shrinking down from 2 down to 1. So it looks something like that in the third quadrant. And then the last leg of the journey is theta going from 3pi/2 to 2pi. There r is going from 1 down to 0. It's getting sucked right back into the origin as your theta goes from 3pi/2 to 2pi. So as r is moving away from the theta axis, you're essentially moving away from the origin in the xy plane. And as r moves towards the theta axis, you're going to be moving closer to the origin in the xy plane. And then as theta is going to the right, like theta goes from 0 to 2pi, you're just rotating your r number line in the xy plane. Now one last detail that we should add here is the direction of movement. Just like with parametric curves, we put the direction of movement, we can do the same thing with these polar equations. So to remind you that as theta increases, you're traveling along this polar curve going counterclockwise. Let's look at example 6. It says graph the curve r equals 2 plus 3 sine theta. First, we're going to draw the graph in the r theta plane. So I'm going to draw a scale in the theta direction, pi/2, pi, 3pi/2, and 2pi. And then in the r direction, up and down, well, let's see, the biggest the sine could get would be 1. So 2 plus 3 times 1 is 5. So we're going to go up 5 at the highest. 1, 2, 3, 4, 5 in the r direction. That's the y-axis essentially. And then the smallest theta could be, the sine theta would be -1. So 2 plus 3 times -1 would be -1. Now right in the middle is going to be where sine theta is equal to 0, which is an r value of 2. So I'm going to go ahead and label that. That's kind of like the center of the sine wave here. We can start by just plotting some theta values in. When theta equals 0, r is going to be 2. When theta equals pi/2, r is going to be 5. And then following the rest of the, well, when theta equals pi, you're going to have sine theta is 0, so r equals 2. And then following the rest of the sine curve, you're going to go down to its lowest point, which we said would be -1, and then back up to the center line. So sine looks something like this. So that's what the graph of r equals 2 plus 3 sine theta is in the r theta plane. But again, we're interested in the xy plane. So r representing a distance from the origin, theta representing the angle. So then we're just gonna take it one step at a time. We have at the beginning theta equals 0 and r equals 2. That's going to correspond with the point 2 comma 0. So that's where we're starting out, 2 comma 0. So if you think, take your theta is 0, that's going to be pointing in the positive x direction, and then your r is 2 would go 2 in that direction. Positive r of 2 would go 2 in that direction. So that's where you would land. Then you're going to end up at an angle of pi over 2 and an r of 5. So that's going to correspond with a point 0 comma 5. I'll go ahead and just estimate where 5 is, something like that. Now, as you're rotating from an angle of 0 to an angle of pi over 2, your r value is going from 2 to 5, so it's moving away from the origin. So that'll look something like this. I'll go ahead and draw the arrow showing direction of movement. Now, as theta goes from pi over 2 to pi, r is going to shrink back from 5 down to 2. So when you get out to pi, you're pointing in the pi direction, you're going to be going r is 2 in the pi direction. So that would correspond with the point negative 2 comma 0. That's going to be where we end up at, that interval of theta values. So it'll be like the same thing, except we're just getting sucked back into an r value of 2. So kind of symmetric about the y-axis here. We'll talk about those symmetries in just a moment, as you can see down below, symmetries. So now as theta goes from pi to 3 pi over 2, it looks like something funny happens. R goes from 2 to 0 and then to negative 1. So at some point, you get an r value of 0, which means that you're going to pass through the origin. When r is 0, that corresponds with a point on the origin. So you're going to get sucked into the origin and actually even go past the origin and have negative r values. So let's see where we're going to end up actually. If we have a theta of 3 pi over 2 and an r value of negative 1, where is that going to be? So if you said that's going to be here at 0 comma 1, then that would be correct. It's kind of strange to think how an r value of negative 1 would correspond with a y value of positive 1. But remember that r is traveling along its own number line. So theta of 3 pi over 2 is going to point positive r down along the y-axis in the negative y direction. So if you have a negative r value, you're going to go the opposite direction, which is up. You're going to go up 1. So that's where you're going to be ending up at when theta is 3 pi over 2. So then again, we're going to think r, as theta goes from pi to 3 pi over 2, r is getting sucked into the origin. It goes past the origin and then ends up at that point right there, 0 comma 1. So that's where that part of the curve is going to be moving. So just for a moment, even though theta is from pi to 3 pi over 2, because the r values suddenly become negative, they pass r equals 0 and become negative, the points that should be in the third quadrant are now flipped over to being in the first quadrant. If you drew a line in the third quadrant and continued it through the origin on, it would go into the first quadrant. So that's where all those negative r values are taking those points, is into the first quadrant. Now the same kind of thing is going to happen as we go from 3 pi over 2 to 2 pi. R is going to go from negative 1 up to 2. So by symmetry, we can see that we're going to come again into the origin and then out to this point at 2, 0. So there's the graph of r equals 2 plus 3 sine theta. Thanks for watching, and see you in the next video.